Hello students, this is Sambhavi. I'm an IITian. I have been giving online courses through UrbanPro platform since 4 years. So I have my own institute. I have been giving classes for BTech, Inter, MSET entrance coaching, IIT entrance coaching, and also all sorts of boards like IB, CBSE, and state. So here I am today presenting you differentiation. So let's see what is differentiation. I'm going to give you a precise idea what is differentiation. Okay, let's get into the topic now. Topics to be covered today are what is derivative, how derivatives helps us solve our real life problems, and differentiation using first principle, some formulas related to it, and some interesting problems. Okay, so what is derivative? I think you would have learned about, you would have known what is the formula for velocity. So we know that velocity equal to distance, displacement by time, isn't it? Also acceleration means change in velocity with respect to time. I'll just write it here. So what is acceleration? Change in velocity, v2 minus v1 by time. So changing with time means dt we say. So that is dv by dt. So did you see? There is something called differentiation. We are doing differentiation here. So before entering into what is derivative, let's talk about movie. Okay, you're watching a movie and some of your friends said there in some particular instance there is a it's so funny to watch it, so you're so curious enough to see that particular instant, that snap. Okay, that's shot. So you're not gonna wait till that shot comes. So you wanted to go directly to that point and open that video and watch it at that particular point. Say if the duration of the movie is 2 hours, you want to watch it at 22, see, for suppose 22 like that. So what happens? You are watching it there a particular instant. It means what? That can be given by differentiation. Now I'm going to tell you what how can we, how these two things are related. I'm going to tell you now. Okay, and if all the images are grouped together, then we say it has integration. Okay, so also in real life, if you see in medicine also, modeling of cancer, like how the cancer is growing and how the disease is spread. In terms of engineering, when we describe the movement of electricity, we have to use differentiation. And also in chemistry, if you want to model the chemical reactions, then you have to use the differentiation. So these are the real life examples that I want to quote. Let's now understand what is derivative. Okay, derivative is the rate of change or slope of a function. So it is all about slope. See, rate of change. So velocity is changing with respect to time. So this is called derivative. So let's see, what is the slope formula? I know you all know the slope formula, and what is that? Slope is equals to change in y by, that is y2 minus y1, we can say, divided by change in x, that is x2 minus x1. So if you have one point here a and the other point here b, and if you want to find the slope, then you just have to say do y2 minus y1 by x2 minus x1. Say this is x2 comma y2 and this is x1 comma y1. So it's as simple as that. You just have to apply the formula and you find how it is changing with respect to x, how y is changing with respect to x. This is what is called slope. Now, okay, have we understood what is slope? So how derivatives help us solve our real life problems? So I told you, if you want to know at particular instant, we use derivative. Let's see how it can be used and see. See, if you have 2 points A and B, it is very easy for you to find the slope, because here you have another set of value, that is x2 comma y2, and here you have x1 comma y1. So it's so simple, y2 minus y1 by x2 minus x1, you can do and you'll get slope, so you can get the slope 24 by 15 or whatever. But what if you want to find slope at one particular point? So see, this is my point. Can you see this? Yes. So this is my point. Now, if I want to find the slope at this particular point, is there any dimensions for that point? Can you see any dimensions for that point? No. It is a particular, it's just a dot. So there, if you want to find what is y2 minus y1 by x2 minus x1, you will get 0 because there is no difference. There is no difference between y2 and y1. So it will be 0. And what about x2 and x1? That is also 0. So this doesn't work. You cannot find a point. You cannot find slope at particular point. So now we understood it's a real serious problem for us to find slope at particular point. So what we did is we took a point. See, already it's just a point. So in that point, I'm zooming it. Can you see? This is the zoomed one. Okay, I'm zooming this point and I'm showing you what I did is we took 2 points in this region only. That itself is a small region. In that only we took 2 points. Say the difference between that 2 points is delta y and delta x. Like in terms of y it is delta y, in terms of x it is delta x. So these delta y and delta y are infinitesimally small, very, very small, infinitesimally small. You would have heard from your teacher saying that it is infinitesimally small. So now you can understand. We are taking one single point. At one single point, it is very difficult to find the slope. In order to overcome that, we are zooming that point and we are considering 2 points in the same region. And in the same region, we are considering the difference between the 2 points as delta y and delta x. Okay, then. So that's why, so what happens now? Slope equal to change in y by change in x, that is delta y by delta x. So say this point is at x and the next point, this one, if this is first point, the second point at delta x distance. And in terms of y, it is at delta y distance. Okay, so what is happening? X, which is, now here it is x. So x is changing to x plus delta x. Okay, x is changing to x plus delta x. And also we say that y equal to f of x is the function given. So y value is changing from, if x is changing to x plus delta x, then y also changed from f of x to f of x plus delta x, because x is changing to x plus delta x, right? So f of x also changes from f of x to, y changes from y of x to f of x plus delta x. So now that we understood that we took say, 2 points in a small region and we considered infinitesimal small difference between the 2 points, distance between the 2 points. So with that note, we got the change in x as x to x plus delta x, change in y as f of x to f of x plus delta x. So according to the slope formula, what is the slope formula? Delta y by delta x equal to, say this is x1, this is y1, and this is x2, this is y2. You just use a formula y2 minus y1 by x2 minus x1. If you do that, this is x1, x2, because I'm talking about x there, no? Yeah. See, this is x value. So if this is x1, this is x2, this is y1, this is y2. As simple as that. Now, let's put this inside this formula, delta y by delta x. So y2 minus y1 means f of x plus delta x minus f of x divided by x plus delta x minus x. So what happens? X gets cancelled, we get delta x. Have you seen this formula anywhere? Huh? So we derived the formula for derivative. Okay, so simplify it as best as we can. So what we have to do is, the only condition is that infinitesimal distance between the 2 points, it should approach 0. Okay, let's see. So that we call it as limit. Shrink towards 0 is actually written as limit. So limit delta x tends to 0, f of x plus delta x minus f of x by delta x is called f prime of x or f dash of x, whatever you call. So this is the derivative. Now you understood how we got derivative. So using this, we'll be able to find the value of the slope at one particular point. So this has made our life simpler, isn't it? So after this, so that's why we write dy by dx is equals to f of x plus delta x minus f of x by delta x. This is our formula. We also call this as first principle, isn't it? Okay, the process of finding a derivative is called differentiation. So let's quickly do an example and understand the concept. Okay, now we have f of x is equals to x square. So we have to differentiate it. Okay, so we have the formula. What is the formula? Limit delta x tends to 0, f of x plus delta x minus f of x by delta x is equal to f prime of x, or derivative of x. So we just have to put the values of x, f of x in this. Like if f of x is x square, what is f of x plus delta x? F of x plus delta x is x plus delta x whole square, because in place of x, what we are putting? We are putting x plus delta x. So f of x plus delta x is x plus delta x whole square. And we know a plus b whole square is a square plus b square plus 2ab. Okay. So now that we got everything, we just have to put that. So I will, you can also see here. So what they did, first they did f of x plus delta x minus f of x by delta x. So what is that f of x plus delta x? We just found x square plus 2x delta x plus delta x whole square minus, what is f of x? It is given x square. Just simply put that x square divided by delta x. So x square gets cancelled, and we have delta 2x delta x plus delta x whole square by delta x. Now what you have to do, take delta x common, then you get 2x plus delta x. So there is a condition, you should not forget that. What is the condition? Delta x should approach 0. That's the limit. So when we put delta x as 0, then we get only simply 2x. So what did you understand? The slope of f of x is equals to x square function or a curve is 2x. As simple as that. Now, having known the first principle, let's see the formulas involved in this. So you don't have to all the time use the first principle formula to derive the to do the differentiation. You can simply learn this formula. So I have given a few formulas. So you can see. So for a constant, the derivative is 0, because if you take any constant, see, this is y and this is x. So if this is constant, it means what? Y is constant. It means what? It is not changing with respect to x. If it is not changing with respect to x, then then we don't get the differentiation, right? So according to us, what is acceleration? Change in velocity with respect to time. So it should change. But here, if it is a constant, the function is constant, it means it is parallel to that, parallel to x-axis. It means y value is constant, right? Y value is constant. Y is constant. So if that is not changing, then the differentiation will be 0. And that's why we have the formula 0. And for a function called, if you have the function as x, it means what? Y equal to mx, you know, right? If it is x, it will be like this. Y equal to x. So we have a formula. What is the equation of the line passing through the origin? That is y equal to mx. So when we compare this, we get m is equal to 1. So slope is 1. So that's why derivative is 1. Simple. And for ax also, we get, if you put a, then we get a. In here, it will be y equal to ax. Then the slope is a. So similarly, we have a lot of formulas to follow. For x square, it is 2x, because we have something called power rule. Okay, we have something called power rule. So if we have x power anything, x power n, x power 3, x power 5, anything, then we have, the formula says n times x power n minus 1, the same. And then if we have two functions, and if the two functions are separated by a plus operator, then you have to individually differentiate each functions and add them. So that's what it is. And f minus g is the same thing. If they are separated by minus operator, then you have to individually differentiate it and then add and then subtract them. So if you have two functions like this, like they are multiplied together, then you have to apply this product rule. That first you have to keep f constant and you have to derive g, plus put g constant and derive f. Then you get the answer. Similarly, we have quotient rule, f by g. So for that, we have a formula. Now I'll just show you some examples. We will do it together. then you will be able to understand. So this is reciprocal rule. 1 by f means we can write 1 by f as f power minus 1. So f power minus 1 is minus 1 times f power minus 1 minus 1 means what? Minus f power minus 2. Either that way you can do. So let's see how to do this using the examples. Okay, these are the questions. I'm going to use a different color to differentiate it. So what is the derivative of f1 1 by x? Okay, 1 by x. So we have a power rule, isn't it? We have power rule, and that says differentiation of x power n is equals to n times x power n minus 1. So here the question says it is x power minus 1. So it will be minus 1 times x power minus 1 minus 1, that is minus x to the power of minus 2. That's the answer for the first question. Okay, and let's see the next question. What is derivative of x square plus x cube? This is see, x square is one function, say f, and the x cube is another function, that is g. They're separated with an operator called addition. So you have to differentiate each individually and then add them. So let's do that. So differentiation of x square plus x cube will be, wait a minute, let me. Okay. So yes, differentiation of x square plus x cube with respect to x only. So that will be differentiation of x square plus differentiation of x cube. Okay, and we know what is the differentiation of x square using the power rule. X power 2 means 2 times x power 2 minus 1. So the answer will be 2 times x power 2 minus 1 plus 3 times, here also same, x power 3 minus 1. That is 2x plus 3x square. This is the answer for the second question. So let's see what is third. What is derivative of 5z square plus z cube minus 7z4? The same thing. You have to follow the same procedure, the power rule only. So differentiation of 5z square with respect to z plus differentiation of z cube with respect to z minus, we can say differentiation of minus 7z power 4 with respect to z. Okay, so 5 is a constant, right? We can keep it aside. So then we'll get differentiation of what? Differentiation of z squared with respect to z plus differentiation of z cube with respect to z minus 7, you can keep aside. So differentiation of z power 4 with respect to z. So now it's simple. You have to use the power, apply the power rule. 5 times 5 into z square means the formula says n into x power n minus 1. That is 2 into z power 2 minus 1. That is 1. And then for this, we have 3 into z power 3 minus 1. And then here minus 7 into 4 into z power 4 minus 1. And the answer is 10 times z plus 3z square minus 28z cube. So this is the answer. Okay. So this is your third answer. Let's see the fourth question. So the answer for the fourth. So what is derivative of cos x into sin x? So we have f into g. It's a product rule. You have to apply product rule. So I told you, first you have to put one, you have to assume one function as constant, and then you have to differentiate the other one, plus you have to keep the another function constant and then differentiate the earlier one. So it means if you have fg, differentiation of fg is equals to put f constant and differentiate g, plus put g constant and differentiate f. So here if we can say cos x as f, we can take this as f and this as g. So in that case we get cos x times differentiation of sin x. So here we have the differentiation of sin x here. Can you see? that is cos x, and differentiation of cos x is minus sin x. Let's apply that. So differentiation of g is sin x. So that is differentiation of sin x is, just now we saw it is cos x plus what is g? Sin x. Just put it there. And differentiation of f is differentiation of cos x means what? Minus sin x. So what we get? Cos square x minus sin square x is your answer. Hope you understood till here. Okay, I'm going to erase this. Okay, we will do the fifth question. Okay, what's the question? We have, what is the derivative of cos x by x? So this is, we have to do this using quotient rule. Quotient rule. Okay, so you say this is u, this is v. I mean, this is u function, this is v function. Differentiation of u by v is equals to v du minus u dv by v square. So what is v? X. Put x. What is u? Then differentiation of cos x. U is cos x, so differentiation of cos x minus u is cos x. Just put it. And differentiation of v is differentiation of x divided by v square means x square. Okay. So just now we saw that differentiation of cos x is sin x. So put x times minus sin x minus cos x, and differentiation of x is 1 divided by x square. So this will be minus x sin x minus cos x by x square. So this is the answer for the fifth question. Hope you all understood it. So this is a simple thing. I just told you the basic concept of differentiation. So thank you so much for your rapt attention. So if you want to learn further from me, you can find me on UrbanPro platform. I'm looking forward to help you in your curriculum. Thank you so much.